Calculus. Just the word itself can sound kind of intimidating, right? It probably brings back memories of these crazy-looking formulas and problem sets that just go on forever. But what if I told you that the big idea behind it all is actually simple and beautiful, and it's something you already get deep down? So in this explainer, we're going to forget the formulas. We're just going to explore the powerful, intuitive idea that's right at the heart of calculus.
So let's just ask the question, point blank. What is this thing really? I mean, if you strip away all the symbols, all the rules, what's the actual idea? What's its soul?
And there it is, right there, the big secret, all in one sentence. Calculus is the math of change. That's it. It's really about two things. One, watching how things change from moment to moment, and two, understanding how all those teeny tiny moments of change can add up to something huge. That's the entire story.
Now, this is a really fundamental shift in how you think about math. See, most of the math you learn before calculus, it's about static things, fixed shapes, constant speeds. But calculus, it's different. It's dynamic. It is the language for describing a world that is always in motion, a world that is constantly becoming something new. This slide just nails the difference perfectly. Think of it like this. Algebra gives you a snapshot, a photograph. It tells you the length of a bridge or the final cost of something. Calculus, on the other hand, gives you the whole movie. It shows you how that bridge is bending moment by moment under stress, or how your profit is changing with every single sale you make. It's the leap from a still photo to a full-motion video.
Okay, so to understand this dynamic world, calculus uses these two incredibly powerful, but actually pretty intuitive ideas. We're going to call them superpowers, because honestly, that's what they feel like. They are the two lenses that calculus uses to see and make sense of all this change.
The first superpower is kind of like having a magnifying glass for time. It's this ability to zoom way, way in on a single fleeting instant and see exactly what's going on. Think about when you're accelerating in a car and you feel your speed increasing, or that feeling of stress slowly building up during a tough day. Calculus gives us the tool to precisely measure that moment-to-moment change.
And this leads us to the crucial question. It's not, what was the average change over the last hour? No, it's what is happening right now. In this exact instant, how fast are you accelerating? At this very second, how quickly is the temperature rising?
And yep, this superpower has a formal name: derivatives. A derivative is just a precise tool for measuring that instantaneous rate of change. You can think of it as the mathematics of right now. It's how we capture the speed, the flow, the acceleration of just a single moment in time. All right, on to the second superpower, which is basically the mirror image of the first one. If the first one was all about zooming in, this one is all about zooming out. It's the ability to take an almost infinite number of tiny, tiny pieces and add them all up to see the big picture. Imagine filling a bucket one drop at a time, or watching your savings account grow penny by penny. And this brings us to the second key question. What's the total result of all those individual moments? If we add up the distance you traveled in every single second of a road trip, what's the total distance you went? If we sum up all the little bits of progress you make each day on a project, what does that final achievement look like? This whole process is called integration, and the result is an integral. An integral takes all those instantaneous changes, the ones we measured with derivatives, and it sums them all up to give us the total accumulation. This is the key. They're two sides of the same coin. Derivatives break things down into moments. Integrals build those moments back up into the complete story. Okay, so we've got these two superpowers, looking at single moments and adding them all up. But why does any of this matter? Well, it matters because these two ideas are the engine behind our entire modern world. I mean it. From the AI on your phone to the way we understand our own brains, calculus is just quietly working in the background. Let's take artificial intelligence. Training an AI model is all about making tiny, continuous adjustments. The AI is constantly asking a calculus question. If I tweak this one little thing, this one parameter, does my answer get slightly better or slightly worse? And by doing this millions and millions of times, it improves, slowly and smoothly. And AI doesn't just leap to an answer, it slides there, and it's guided by the principles of calculus. And this just brilliantly sums it all up. Every time you hear about an algorithm optimizing or learning, that little word, slightly, that is calculus in action. It's the mathematical engine of gradual improvement. But it's not just for computers, Think about psychology.
Our mental states don't just jump from happy to sad. Burnout doesn't happen overnight. It's a slow accumulation of tiny stressors. Habits are formed through the gradual stacking of one daily action on top of another. Calculus gives us a language for this continuous, flowing nature of our own inner lives. And the same is true for biology. A doctor needs to know how a drug's concentration is changing moment by moment in your bloodstream to figure out a safe dose. Ecologists model population growth not as big jumps every year, but as a continuous flow. Our bodies aren't spreadsheets that update once a day. They are dynamic systems, constantly in flux.
And of course, there are the classic examples in engineering and physics. Anytime something moves, or bends, or flows, or vibrates, calculus is right there. From making sure a bridge can handle the changing stress of traffic, to guiding a rocket on its perfect arc into space, calculus is the invisible framework that keeps our physical world stable and predictable.
So as we pull back, we start to see that calculus isn't just a toolbox for solving technical problems. It's a profound way of seeing the world. It's a language that was designed to describe the very nature of reality, which is one of constant, unending change. You know, maybe the fear around calculus comes from all the symbols and the mind-bending idea of infinity, but the core concept is actually very gentle. It just recognizes that life doesn't happen in these big, jarring steps. It flows. And calculus is just the beautiful, precise language humanity came up with to listen to that flow.
I honestly cannot think of a better way to say it. In a universe where everything, from galaxies down to our own thoughts, is in a constant state of becoming something else, calculus is the native tongue. It's the grammar of growth and motion and transformation.
So in the end, the goal isn't just to solve an equation. The real reason to appreciate calculus is to get a deeper understanding of the world around you and the world inside you. When you really get that simple, powerful idea that calculus is just the language of change, well, the formulas start to look a lot less scary. They're just the details. The real story is about seeing the world in motion.